Hello, let's solve a math path puzzle. This is called 20 something by Thomas Snyder. There's a link in the description. I sourced this from GM Puzzles. So what we need to do is we need to place a digit from 1 to 15 in every single cell, and we can't repeat any of the digits. So each cell will have 1 to 15. None of them will repeat. What we need to do is we need to path consecutive numbers. So I don't know where to start, but like 1, 2, 3, 4, 5, 6. We can go diagonally, 7, 8, 9, 10, etc. Right? I've not built a good path here, but you can see that we're building a path by either sharing edges, sharing diagonals. It's just adjacent. Every digit is adjacent to its up to 2 consecutive digits. Is another way to put that. I guess that might not be the best way to put it. We have to make a path of consecutive digits, but the path can go diagonally. Anyway, the way that we do this is in each of these regions may have a number and an operation. So they're all 20s in this puzzle. They don't have to be, but that's the theme of this puzzle. So these all multiply to 20. So if we just multiply each of the digits, they multiply to 20. So do these two. These do a mystery operation to 20. The available operations are add, multiply, divide, or subtract. If you're dividing or subtracting, you start with the big number and then you move your way down and just keep applying that operation. So 4, 2, 1 would be 4 minus 2 minus 1, which is 1, and that would be the sum, and that would have to match the corner. All right, that's it. Those are the rules. I'm going to get started right now. All right, so thinking about multiplying to 20, the prime factors are 2, 2, 5. And we can't repeat the 2. So we're either going to be doing 4 times 5 or 1 times 2, or sorry, 4 times 5. I got ahead of myself. 4 times 5 or 2 times 10. But I know that I need 3 digits to multiply over here. Since we can't do 2, 2, 5 because we have to repeat the 2. We're going to put the 1 in here. And so it's either going to be 1, 2, 5, sorry, 1, 2, 10 or 2, 4, 5. What's wrong with me? 1, 4, 5 or 1, 2, 10. And then this is going to be the other one without the 1. But if we tried to make this 2, 10 in some way, the 1 would be over here and not next to the 2. We couldn't path to the 2. So we're not going to do that. This is going to be 1, 2, 10. And this is going to be 4, 5. And the 3 can't go, multiplication to 20. We're out of multiplications. We're not going to subtract or divide to 20 because we can't get above 20 in the first place. So these are all going to be adding to 20. There's 4 of them. We can do... Well, we can't, 1 is gone. We can't do 1 plus 19. Well, why don't I think about this first? So this is going to be 1, 2, 10. This is going to be 4, 5. We can't do 3, 17 is, I guess, my point. So the 3 is going to go here. It has to. And it's going to be next to the 4, and then that's next to the 5 here. Now over here, this is going to just have to be the 2, because the 2 is in here in this gauge. We're going to go down. Well, this could be 1. Oh, okay. Well, if I made this 10, I guess I could go to 11 here. All right, so we got to be careful here. This is 1 or 10. This is 1 or 10. They're both next to the 2, and they both can escape, so we don't know the order yet. But now we have to place the 6 somewhere. I think we have to go here, because we have to use this cell on the path. And if we skip it, going back would dead end us. So this is just the 6, and then we have to go to the 7 here. And 7's going to be next to the 13 to add to 20. We know these are all adds. And so now this just, the 7 has no choice but to go to 8 here, and the 8's going to be next to 12. So 12 is next to 13. Now the 8 is going to have to go here to make a 9, and 9 is next to 11. 11's going to go to one of these 10s. And now this is, we need 2, 3, 4, 5, 6, 7, 8, 9. We need a 10. Wait. The problem is this can't be 10. Was there another way to do this? 6, 7, that's 13. So this goes to 8. 6, 7, 8. This has to be 12, and so this goes to 9. 9 plus 11 is 20. But then could this be 10 somehow? Shoot, did I miss a case where this can... 3 couldn't go in these 20s because we can't do 3 plus 17 and it's not divisible by 20. So 3 is here or here for sure. Maybe I don't know. Was there another way to do this? Could this be the... This can't be the 15. Where does 15 go, though? Hold on. So I'm gonna erase these. I thought I was doing it. Honestly, I thought I was doing it. Was there another way to do this? I mean, this could be 4, 5, but there's only 2 ways to multiply 20. So 2, 10, and 4, 5. The problem is, where does the 15 go? Because we can't do 15 plus 5, because 5 is already used in this 20 cage. So one of these is 15, one of these is 3. So could we have done... Ooh, actually, could we have done 3 here, 2 here? Well, no, 1's over here. That's the problem. This has to use the 1. No, okay. But I'm thinking 3 and 15 are the one. Well, where's 4 go? Because we don't have 16. Tell me I didn't do a 4, 16. No, I didn't. No, 4 is in here. 4 and 5 are in here. 1, 2, and 10 are in here, I'm pretty sure. Let me just write that out. 1, 2, 10. 1, 2, 10. 1, 2, 10. I thought I had this. I thought I was almost done. Maybe I was and I stopped early, but like we got to bridge the 1 and 2 over here to the 4 and 5 here, and we only get 1 cell to do it, so it's got to touch them both. This could do it, but how are you putting a 3 and a 20? Right. So okay. So the digits that we're concerned about are 3 and then 6 through 15 other than 10. And so to get to 20, 15 is the only one that can't get to 20 other than 3. So this is 3 and 15, and this is 3 and 15. And then the rest of them are just adding to 20 using the 6 through 14. So how are we making a path here? That isn't the one I just made. So this one needs to be next to the... This path has to do this angle, right? That's the only choice. I kind of feel like drawing a line might be helpful here. We have to take this corner. There's no choice there, because this... Well, the path could end at 15, actually. So if the path ended at 15... Oh, so maybe that's what I missed. So I think all I need to do here, I think I was right otherwise, is this is 2, this is 3, this is 4, this is 5, and we don't go to 6 here, because this can't be 6. This is our 15. We're going to end at 15. So this is going to have to be 14 plus 6. Oh, there we go. Now the 14 has to go to 13, and we're going to do 13 plus 7. Now the 13 has to go to 12, and we're going to do 12 plus 8. Now the 12 has to go to 11, which is going to be here, and we're going to do 11 plus 9. That makes this the 10, so it's next to the 9. And so it's going 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then finally our 1 is right here. There we go. I missed the... Yeah, that was tricky. I assumed we had to take this corner, and I forgot that you could just end 15 there. So we had to think about how 15 wasn't available to go into one of these sums. I wish I had realized that earlier. All right, well, how'd you do?